All right, good morning and welcome to Master Talker online class. In today's video, we'll be solving out some questions on binomial expansion. All right, so this first question, question number 29, and please, if today is your first day of watching our video, please subscribe. This one said that for what value of y is the binomial expansion this valid? You want to check the validity of a binomial expansion, you take the absolute value of that 2y, okay, is less than this one. The absolute value of this one should be less than this one. So what do we have? Now to remove absolute value, you have that minus 1 is less than 2y, okay? Minus 1 is less than 2y, which is less than 1. So what do we do? Divide everybody by 2 to have minus 1 over 2 is less than y, which is less than 1 over 2. So therefore, y is an element of an open set of minus 1 over 2 and 1 over 2. So that is that. You see, it's very, very simple. So let's look at the next question by the right hand side. This one said we should find the coefficient of the term uh, x squared y raised to power 10 in the expansion of this. Now, anytime you want to find a particular term in a binomial expansion, all you need is just the formula n combination r a raised to power n minus r b raised to power r. Okay, so and you know that a plus b all raised to power n. If I compare it with this 3x minus y squared all raised to power 7, it will show you that my a is equal to 3x and my b is equal to minus y squared and my n is equal to 7. If you look at this formula now, the only problem is my r. I don't know my r. But before that, let us substitute the one we already know. So we can say 7 combination r. Instead of writing a now, I'll write 3x. So 3x all raised to power what? 7 minus r. Then I'll now write what? Minus y squared raised to power what? R. Now bring out all the constants. If I bring out all the constants, I have 7 combination r. 3 is a constant. I'll say 3 raised to power 7 minus r. Then minus 1 is standing here. So I will say minus 1 raised to power r. Then I will now have the variables x raised to power 7 minus r. Then y raised to power, this time this, 2r. All right. Now compare this now with what you have. Compare this with what you have. So you can say that what? That x raised to power 7 minus r should be equal to what? The x squared here. And y raised to power 2r should be equal to y raised to power 10. So if x take care of x, I'm having that 7 minus r is equal to 2. If y take care of r, I'll have that what? That 2r is equal to 10. So collect items to have 7 minus 2 is equal to r, and r is equal to 10 divided by 2. So therefore, r is equal to 5 here, and r is equal to 5 here. So you must get that r are the same thing. If you did not get the same thing, then there is a problem somewhere. Say, come back and put it in this last formula you got. So which is what? 7 combination 5, 3 raised to power 7 minus 5 will give you 2. So 3 raised to power 2 in bracket of minus 1 raised to power 5. Then x raised to power what? This minus this will give you what? 2. And then y, 2 times 5, I have what? 10. So what do you have finally? So this is equal to, let me press 7 combination 5 is giving me 21. So I have 21 times 9, then times minus 1, because this is raised to power odd number. Then I have x squared y 10. So finally the coefficient becomes 21 times 9 times minus 1. So the coefficient is equal to minus 189 is the coefficient. So you see, it's very, very simple. So let's look at the next question. So the next question said that we should find the next question said, that is question number 122. Question number 122 said we should find the coefficient Oh, there is no question number 121. So this is question number 122. So let's talk about question number 123. Question number 123 said, Question number 123 said, 0.777 ... It continues with that 7 is equivalent to what? Equivalent to, they said A is equivalent to 7 over 33. B is equivalent 7 over 9, C 7 over 10, and then D 9 over 7. So just press your calculator. I know that 7 divided by 9 will give me 0.777777. So the answer is simply B. All right. So that is that. This one is very, very simple. So let's move to question number 124. Question number 124. So I'm going to have, they say find the term independent find the term independent of what? Of P in the expansion of 3p squared over 2 minus 1 over 3p, then everything raised to power 9. Okay, so we are looking for the constant term. Whenever you hear the term that is independent of, it means the constant term. So the same thing is applicable whenever you are looking for a particular term in a binomial expansion. Don't forget you are going to use n combination r, a raised power n minus r, b raised power r. So if you compare this the way I did this, you'll be seeing that your a is equal to 3p squared over 2 and your b is equal to minus 1 over 3p. All right, so and then your n is equal to 9. So the only problem I have is my r. So let me put the ones I already know. So I'm going to say 9 combination r. My a is 3p squared over 2 all raised power 9 minus r. Then I have minus 1 over 3p raised power what? Raised power r. So bring out all the constants. I'm going to have 9 combination r, then 3 over 2 all raised power 9 minus r, then minus 1 over 3 all raised power r. So these are all the constants. So when you come to the variable, I'm going to have p squared raised power what? 9 minus r, and then 1 over p raised power what? R. Okay, so if you have this now, you are going to say, let me make all the r to stand one place, and I want to have just one r. So I'm going to have 9 combination r, just one p, sorry, because we apply indices here. So I have 3 over 2 raised to power 9 minus r, then minus 1 over 3 raised to power r. So I'm going to have p raised to power, this time this is 18, this time this is what? 2r. All right, then here will now be p raised to power minus r, because 1 over p means p raised to power minus 1. So times r, I have this. So we are applying indices. I have 9 combination r. I have 3 over 2 raised to power 9 minus r, then minus 1 over 3 raised to power r. I'm going to have p raised to power 18 minus 2r minus r will give you minus 3r. All right, so now they say we should find a term that is independent of p. So the term that is independent of p means p raised to power 0. That is the constant term. So we now say the term that is independent of p will now equate p raised to power 18 minus 3r is equal to p raised to power 0. All right, so if p take care of p, I have that 18 minus 3r is equal to 0. So therefore 3r is equal to 18. My r will now be 18 divided by 3, which is equal to what? 6. Since I've gotten my r, come back to the last formula you got and substitute. So I have 9 combination 6. I'm going to have 3 over 2 raised to power what? 9 minus 6. Then minus 1 over 3 raised to power what? 6. And p raised to power what? 18 minus 3 into 6. Okay, so what do we have? 9 combination 6. 9 combination 6. I have 84. So I have 84 times 9 minus this is 3. So 3 raised to power 3 will give you 27 over 8 times 3 raised to power 6. 3 raised to power 6. So I have times 1 over 729. Then times, this is 0. Anything raised to power 0 is 1. So multiply the numerator, then multiply the denominator. So I have for the denominator is times 8. So I have 5832. For the numerator, I have 84 times 27. So you have 2268. So if you reduce to the lowest, divided by 5832. So I have 7 over 18. So that is the term that is independent of p. So that is that. Okay. So we move to the next one, question number 125. Question number 125. Question number 125. Okay. For question number 125, I have they say find the fifth term, they call it T5, in the expansion of x raised to power 2 plus 1 over x squared all raised to power 10. All raised to power 10. Okay, so this is a very simple question. So what do you do? Solution. The same thing is applicable now, but in this one I told you, anytime you want to find a particular term in a binomial expansion, don't forget we are still using any combination r, a raised to power n minus r, b raised to power r. So comparing this, if you want to compare this with your a plus b raised to power n, it will show you that my a is equal to x squared, my b is equal to 1 over x squared, my n is equal to 10. But to get r here, they say we should find the fifth term. So to find the fifth term is 5 minus 1, which is equal to 4. So your r is 4. Now put everybody. So you have what? 10 combination 4. Okay. X squared raised to power what? 10 minus 4. Then what? 1 over x squared raised to power what? 4. So what do we have? Press 10 combination 4. 10 combination 4. I have 210. So I have 210. X raised to power 10 minus 4 is 6. 6 times 2 is what? 12 times 1 over x raised to power 2 times this 8. So according to this is 210 x raised to power what? 12 minus 8. So I have what? 210 x raised to power what? 4. 12 minus 8, 4. Okay, x raised to power 4. So this is the fourth term. So this is the fifth term of that binomial expansion. Very, very simple. We move to the next question. Question number 126. Question number 126. For question number 126, they said find the coefficient. Find the coefficient. 126 said find the coefficient of x squared in the expansion of, find the coefficient of x squared in the expansion of 1 plus x raised to power what? 2 over 3. 2 over 3. Okay, this is a very simple this thing. Now whenever you have 1 plus any binomial expansion that starts with 1 plus raised to power anything, the formula is very simple. Just say 1 plus nx, okay, plus n into n minus 1. This is 2 terms, x squared over 2 factorial, okay, plus n into n minus 1, n minus 2, okay. This is 3 terms, 1 2 3. So I'm going to have x raised to power 3 over what? 3 factorial plus dot dot dot. It continues that way, but they say we should find the coefficient of x squared. So this is where we have for x squared. So for x squared, we have that n into n minus 1 all over 2 factorial x raised to power 2. So if you substitute here, you are going to have my n means 1 over 1, the power here 2 over 3. So I'll say 2 over 3 into 2 over 3 minus 1, then x squared over what? 2 factorial. So what do we have now? That is 2 over 3 into 3 times 1, 3. 2 minus 3 is minus 1. Minus 1 over 3, then x squared over 2 factorial is 2 times 1, which is 2. So multiply the numerator. This 2 times this, I have minus 2 all over the denominator. 3 times 3, 9. 9 times 2, 18. So I have 18x squared. So which will give me minus 1 over 9x squared. So that is, so the coefficient is now minus 1 over 9. The coefficient is minus 1 over 9. Okay, very, very simple. We move to the next question. Question number 127. Question number 127. So for question number 127, we have find the coefficient. Find the coefficient of x raised to power 3. Find the coefficient of x raised to power 3 in the expansion of 2x minus 3 over x, everybody raised to power 3. Okay, so we want to find the coefficient of that. Now, very, very simple solution. The same method to find any particular term before you now talk about finding the coefficient. We are going to use the formula n combination r, a raised to power n minus r, b raised to power r. So according to this place, my a is equal to that 2x, my b is equal to minus 3 over x, and my n is equal to what? 3. I don't know my r. So let me put the ones I already know. So I have what? 3 combination r, then my a, which is what? 2x raised to power what? 3 minus r, then minus 3 over x raised to power what? R. Okay, so if we have this, we are going to bring out all the constants first. So 3 combination r, then the constant here is 2. So 2 raised to power 3 minus r, then the coefficient here is what? Minus 3 raised to power r. For the variable, I'm having x raised to power 3 minus r, then I'm having 1 over x. In fact, 1 over x raised to power r. Okay, so and 1 over x raised to power r. So this is 3 combination r, 2 raised to power 3 minus r, then minus 3 raised to power r. Then I'm having here x raised to power 3. Then you know that here should be minus r. So minus r give me minus 2r. So equate this thing to what you are looking for. I'm looking for the coefficient of this man. So I will say that x raised to power 3 minus 2r, okay, 3 minus 2r is equal to that one I'm looking for, x raised to power 3. This take care of this. I'm going to say that 3 minus 2r is equal to what? 3. Collect like terms. I'm going to have that that r is equal to r there is equal to 0. So if you look at that, you're going to see that what? That 2r is equal to 3 minus 3. So 2r is equal to 0. So r is equal to what? 0 divided by 2, which is what? 0. So if r is 0, let us put it in the last part and see what happened. So I have 3 combination 0, 2 raised to power 3 minus 0, then minus 3 raised to power what? Minus 3 raised to power 0. Okay, then I'm going to have x raised to power what? 3 minus 2 into 0. So what do I have now? 3 combination 0, 3 combination 0 is 1. So I have 1 times, okay, there is 0 here. So this raised to power this is giving me 8. Anything raised to power 0 is 1. Okay, then I'm having x raised to power 3. So I have 8 x raised to power 3. So the coefficient is just 8. So the coefficient is just 8. All right, very simple. So we move to the next question. We move to the next question, and the next question here said, that is question number 129. 129, and 129 say determine the third term in the expansion of 1 plus 2x all raised to power what? Minus 3 over 4. Okay, want to determine the third term. Now this is very simple. I told you something, that anytime a binomial expansion starts with 1, I have 1 plus anything at all raised to power n. That the formula is what? 1 plus nx plus n into n minus 1, 2 terms all over what? 2 factorial x squared, and it continues that way. So this is the first term, this is the second term, this is the third term. So for the third term, we have that what? N into n minus 1 all over 2 factorial x squared. So if you compare this with 1 plus x raised to power n, you will now see that anywhere I see x, I will replace it with 2x. This and this is in the same position. And anywhere I see n, I will replace it with 3 over 4 because they are on the same position. So this is equal to what? Minus 3 over 4 into minus 3 over 4 minus 1 all over what? 2 factorial is 2. Then inside here, I'll be having what? 2x all squared. So what do I have? Minus 3 over 4 into 4 times 1, 4. Minus 7 over 4. Okay. Then I have 4 here. 4x squared. Okay. All over 2. This can take care of this to have 2 here. So, and this can take care of this to have 2 here. So I'm left with the numerator 3 times 7 is 21 all over the denominator. 4 times 2 is 8. Then I have x squared. So the coefficient, okay, the term, okay, this is the answer. So 21 over 8 x raised to power 3. Sorry, x raised to power 2. So that is the answer. So let's go to question number 130. Question number 130. Question number 130 said, please, if you have not watched my video on binomial expansion, please do that so that you can be able to understand this. So they said that the term independent of x in my 3x squared over 2 minus 1 over 3x raised to power 9 is, okay, solution. Want to find the term that is independent of x. Want to find the term that is independent of x for question number 130. The same thing is applicable. We want to find a particular term. Anytime we want to find a particular term, we are still going to use our n combination r, a raised to power n minus r, b raised to power r. And if you check this is my a, this is my b. My a is equal to 3 over 2x squared, and my b is equal to minus 1 over 3x. While my n is equal to 9, my r is unknown. So r is the main thing I want to find. So let us put the one we already know. So I can say 9 combination r, then I have 3x squared over 2 raised to power 9 minus r. Then I'm going to have minus 1 over 3x raised to power what? R. Very, very simple. So let's bring out all the constants. I'm going to have 9 combination r, then 3 over 2 raised to power 9 minus r, then minus 1 over 3 raised to power r. Then I'm having x squared raised to power 9 minus r. Then I'm going to have minus 1 over x raised to power r. Okay, so this is what? 9 combination r, 3 over 2 raised to power 9 minus r, minus 1 over 3 raised to power what? R. Then x raised to power, this time this 18, this time this, you have a minus 2r. Then this one will give you minus r again. Okay, so minus 2r minus r will give you minus 3r here. So I have minus 3r. So we want to get the term that is independent of x. So the term that is independent of x means we should equate that x raised to power 18 minus 3r to be x raised to power 0. Okay, if x take care of s, I'm going to have that 18 minus 3r is equal to 0, which will now show me that r is equal to 6. Okay, so from here I'm going to see that what? That 18 is equal to 3r, therefore r is equal to 18 by 3, which is what? 6. So immediately you have gotten that, put it in the last expression. So the last expression here said 9 combination 6 into 3 over 2 raised to power 9 minus 6, okay, minus 1 over 3 raised to power 6. Then I have x raised to power what? 18 minus 18, because 3 times this, okay, 3 into 6. So what do we have now? 9 combination 6. 9 combination 6. I'm going to have 84. So 84 times 9 minus 6 is 3. So 3 raised to power 3 is 27 over 8. Okay, times 1 over 3 raised to power 6. 3 raised to power 6. So I have 729. Then x raised to power 0. And x raised to power 0 is 1. So I'm left with, for the numerator, times 8 for the denominator. So I have 5832 for denominator. For numerator, I have 84 times 27. Okay, so which will give me 2268. So do everything divided by 5832. So I'm having 7 over 18. 7 over 18 as my last answer. So that is the term that is independent of x. So let's go to question number 131. Question number 131. So for question number 131, I'm going to have that they say we should find the coefficient of t raised to power 7. Find the coefficient of what? T raised to power 7 in the expansion. In the expansion of 2t minus 3 over t raised to power what? 15. Okay, this is a very simple question in binomial expansion. The same thing is applicable. we are looking for a particular term. So the same formula, and the formula is what? Any combination r, a raised power n minus r, b raised power r. So from here, I will know that my a is equal to 2t, and my b is equal to minus 3 over t, and my n is equal to 15. The only problem I have is my r is unknown. So let me substitute the people that I already know. So for the people I already know, I'm going to have 15 combination r, then 2t raised to power 15 minus r, then minus 3 over t raised to power r. Bring out all the constants. I have 15 combination r, constant 2 raised to power 15 minus r, constant minus 3 raised to power r. Okay, then for the variable, t raised to power 15 minus r, and then 1 over t raised to power r. Okay, so here I'm having 15 combination r, 2 raised to power 15 minus r, then minus 3 raised to power r, then I have t raised to power 15 minus r will give you minus 2r. Okay, so getting to this place, we are looking for the term that the coefficient of t raised to power 7. So we now say that t raised to power 15 minus 2r, okay, is equal to t raised to power 7. So if t take care of t, we are going to be having that 2r. If t take care of t, I'm going to have that what? 15 minus 2r is equal to 7. So therefore, 15 minus 7 is equal to 2r. Okay, 15 minus 7 is 8. 15 minus 7 is 8. Okay, so therefore 2r is equal to 8. So r is equal to what? 8 divided by 2, which is what? 4. Immediately you have gotten your r, put it in the last expression. So I have 15 combination 4, 2 raised power 15 minus 4, then minus 3 raised power 4. Then I'm going to have t raised power what? 15 minus 2 into 4. Okay, so what do we have? 15 combination 4. 15 combination 4. I'm going to have 1365. 1365 times 15 minus 4. 15 minus 4. I'm having 11. So 2 raised to power 11. 2 raised to power 11. So I have times 2048. Okay. Then minus 3 raised to power 4. That is 3 raised to power 4. 81 times 81. Then times t raised to power what? 2 times 4, 8. 15 minus 4. You have 15 minus 8. Sorry. So I have 7. T raised to power 7. So multiply all these people. Now I have 1365 times 2048 times 81. I'm going to have 226437,120 t raised to power 7. So the coefficient of t raised to power 7 is now equal to what? 226437,120. So that is the coefficient. Very, very simple. We move to the next question. That is question number 132. Okay, they don't have number 132. So we move to question number 133. So question number 133. Question number 133. So for question number 133, they say the first three terms, the first three terms in the expansion of the first three terms in the expansion of 1 minus 2 over y raised to power minus 3 is. So we want to get the first three terms. To get the first three terms solution, I told you whenever a binomial expansion starts with 1, so I have 1 plus x raised to power n. So it's equal to what? 1 plus nx plus n into n minus 1 x squared over 2 factorial plus dot dot dot. It continues. They say we should find the first three terms. Look at the first three terms. So if you compare this one and this one, it shows that my anywhere I see x, I will replace it with minus 2 over y. And anywhere I see n, I will replace it with minus 3. So in this formula, I'm going to have that 1 minus 2 over y all raised to power minus 3 is equal to 1 plus n is here. So I'll put what? Minus 3. Then x is here. I'll put minus 2 over y. Okay, plus. We continue that way. We have again n. N is what? Minus 3 into minus 3 minus 1 all over what? 2 factorial. Instead of writing x, you have minus 2 over y all squared. okay, then plus dot dot dot. So my final answer is now 1. This and this will give me 6, so plus 6 over y, okay. I have minus 4 here. 2, take care of 2 here, I have 2, so 3 times 2 6. I still have 6. 6 times 4 24, so I have 24 over y squared, then plus dot dot dot. So these are the first 3 terms of that binomial expansion. So we move to question number 134. Question number 134, okay. Question number 134 said, find the seventh term, find the seventh term in the expansion of x plus 1 over x squared all raised to power 15. Okay, so solution. This is very, very simple. Anytime you are finding a particular term of a binomial expansion, the formula does not change. N combination r, a raised to power n minus r, b raised to power r. Comparing this, I have that my a is equal to x, my b is equal to 1 over x squared, and my n is equal to what? 15. So my r is equal to, they say I should find the seventh term. So my r will be 7 minus 1, which is 6. So put everybody now to have what? 15 combination 6. 15 combination 6. My a is what? X raised to power what? 15 minus 6, then 1 over x squared raised to power what? 6. So if you do that, you are going to have 15 combination 6. 15 combination 6. I'm going to have 505. 5005. I have x raised to power 15 minus 6. So I have 9. X raised to power 9. Then I have here 1 over x raised to power 12. So I'm going to have 5005 x raised to power 9 minus 12. So 5005 9 minus 12, I have minus 3. So x raised to power minus 3, which can be written as 5005 over x raised to power 3. So any of the two is the correct answer. Okay, so we move to the next question. Question number 135. See, binomial expansion is very simple. So question number 135. Question number 135. So 135, example 135. So I have the 12th term in the binomial expansion. So they say to find, the same question again. Find the 12th term in the expansion of the same thing again. In the expansion of x plus 1 over x squared raised to power 15. All right, the same thing is applicable. Anytime you are looking for a particular term in a binomial expansion, we use a formula that says that any combination r, a raised to power n minus r, b raised to power r. So comparing, I have that my a is equal to x, my b is equal to 1 over x squared, my n is equal to 15, my r is equal to 12 minus 1, which is 11. So put everybody now. 15 combination 11, okay, x raised to power what? 15 minus 11, then what? 1 over x squared, all raised to power what? 11. All raised to power 11. So what do we have now? We're going to have 15 combination 11. 15 combination 11. I have 1365. So 1365. S is power what? 15 minus 11. I have 4. Then I have 1 over s is power 22. So what do I have? 1365. S is power 4 minus 22. So I have 1365 x is power what? Minus 18. So which is certain as what? 1365 over what? X raised to power 18. So this is very, very simple. We move to the next question. Question number 136. Question number 136. 136. So for question number 136, I have question number 136 said, find the term in the binomial expansion that contain find the term in the expansion of, okay, there's no 136 but 139, sorry, 139. So in the expansion of 2x plus 3y raised to power 11 that contain x raised to power 6. Okay, the same thing is applicable. Solution very very simple. Anytime you are looking for a particular term in a binomial expansion, our formula does not change. Any combination r, a raised to power n minus r, b raised to power r. All right, so put everybody here. My a is equal to 2x, my b is equal to 3y, and my n is equal to 11. The only problem is my r. So let me put the people I already know. 11 combination r, okay, 2x raised to power 11 minus r, then 3y raised to power what? R. Okay, bring out all the constants. 11 combination r, 2 raised to power 11 minus r, 3 raised to power r, then x raised to power 11 minus r, y raised to power r. Okay, so now if you look at this place now, they say we should need the term that contain s raised to power 6. We'll tell them that s raised to power 11 minus r is equal to s raised to power 6. So s take care of s. I'll see that 11 minus r is equal to 6. So r is equal to what? 11 minus 6, which is equal to what? 5. Once you have gotten your r, put it in the last expression. So if you put it in the last expression, we are going to have 11 combination 5, okay, 2 raised to power 11 minus 5, then 3 raised to power 5, x raised to power 11 minus 5, y raised to power what? 5. So what do we have? 11 combination 5. 11 combination 5. I have 462. So 462 times 2 raised to power 6. 2 raised to power 6, 3 raised to power 5, x raised to power 6, y raised to power 5. So we have 462 times 2 raised to power 6. 2 raised to power 6. So I have 64 times 3 raised to power 5. I have 243, then x raised to power 6, y raised to power 5. So if you multiply everybody times 64 times 462, so I'm having 729 7290 x raised to power 6, y raised to power 5. So that is the term that contain x raised to power 6. So we move to the next question. Question number 140. So question number 140, that's the second to the last question I'm going to solve here. Question number 140 said we should 140. They say expand the square root of 1 plus x in increasing power of what? X up to x raised to power 3. Okay, this is very very simple. Solution: I told you that whenever a binomial expansion starts with 1, there is something you need to do. So we say that what? 1 plus x all raised to power n. It has a formula which is what? 1 plus nx plus n into n minus 1 all over 2 factorial x squared plus n into n minus 1 n minus 2. Okay, so x raised to power 3 over what? 3 factorial plus dot dot dot. It continues. So now look at the question they gave us. They gave us the square root of 1 plus x. This thing is now saying 1 plus x raised to power 1 over 2. So if you compare, you see that anywhere you see n now in these two things, just put 1 over 2. So I have that what? That 1 plus x all raised to power what? 1 over 2 is equal to 1 plus 1 over 2x, okay, plus 1 over 2 into 1 over 2 minus 1 all over 2 factorial x squared plus 1 over 2 into 1 over 2 minus 1 1 over 2 minus 2 x raised to power 3 over what? 3 factorial. So if you have this, I'm going to have 1 plus 1 over 2x plus, now this is 1 over 2 into minus 1 over 2 all over 2 here x squared, because 2 factorial is 2 times 1, which is 2, plus here is 1 over 2 into minus 1 over 2 into minus 3 over 2, then x squared over 6. Okay, so the numerator multiply the numerator, the denominator multiply the denominator. So I have 1 plus 1 over 2x. For numerator, 1 times minus this, I have minus 1 all over the denominator. 2 times 2, 4. 4 times 2, 8. I have 8. So I have x squared here plus dot 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 plus dot dot dot. So I have, for here, minus is plus. I'm going to have plus here. So 1 times 3 is 3 for numerator. For denominator, or 3 can take care of here to have 2. So for numerator, I'm going to have 1 all over 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 1 over 16 x raised power what? 3 s cubed, okay, plus dot dot dot. So that is the expansion. It's very, very simple. We move to the next question. The next question said, and which is the last question, they said find the expansion of this. The same thing now. Question number 141, but there is 3 here, cube root. Okay, so what do? We change this to 3. Very, very simple. You just change it to 3. Very, very simple. So okay, the same question. So what do? We have 1 plus x all raised power what? 1 over 3 now. So what do? 1 plus 1 over 3 x plus 1 over 3 into 1 over 3 minus 1. Okay, I have all over what? 2 factorial x squared plus 1 over 3 into 1 over 3 minus 1, 1 over 3 minus 2, x raised power 3 over what? 3 factorial plus dot dot dot. That's how it continues. So this is equal to 1 plus 1 over 3x plus 1 over 3 into 3 times 1, 3. 1 minus 3 is minus 2. So I have minus 2 over 3, okay, all over 2. Then x what? X squared plus 1 over 3 into minus 2 over 3 into 3 times 2, 6. 1 minus 6 is minus 5 over 3, okay, x is power 3 over 6. So what do now? 2 can take care of 2 here, okay, and 2 can take care of 6 here to have 3. So what do? For numerator, 1 plus 1 over 3 x plus numerator here is what? Plus minus is minus. So I'm having minus here. 1 for the numerator. Denominator 3 times 3, 9. So I have x cubed. Okay. Minus minus is plus. So I'm having plus here. For numerator, I'm having 5 for numerator. For denominator, I have 3 times 3, 9. 9 times 3, 27. 28 times 3 is 81. 5 over 81. I'm having s raised power 3 plus dot 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 plus dot dot dot. So that is that. So thank you very much for watching. In our next video, we talk about solution of inequalities. Bye bye. Please like, share, and subscribe.